lab there. We'll talk about that when class goes on. It's basically something every day of the week. So it's going to be a lot. It's going to be really fun. It's going to be a lot of work, but good work, like hard work. If this were too easy, you wouldn't really be learning something. You learn when something's hard, and you're like, I want to get over that hump, and you get over the hump, you're like, wow, I just climbed that mountain. I learned something today. That's awesome. So it's going to be that. So don't think it's going to be a cakewalk, but we have tons of people who are here with me in the CS10 family who have gone through the class, love it, and have given back as a TA, as a lab assistant, as a reader. I don't think there's a single class on campus, I'm going to argue, no single class on campus that has the most number of students returning to help the class, which is awesome. So we're really proud about that result, that students just love this thing and they want to be part of it. It's just great. Those of you who came in late, you may notice we've got a camera here and a weird green screen. And you may ask me what that's about, and I'm glad that you are asking. Got 3 minutes, stalling for 3 minutes. We are recording this for archival purposes. So we are actually putting together an online class, and we're going to be recording the lectures live for the online class. And you might say, well, doesn't that mean that we can't ask questions because I'm recording it for the camera? Yes, but I'm going to record 5 minutes and no more than 5 minutes, and then stop all the questions you want. And then 5 minutes, and then all the questions you want. So it's going to be kind of like blips of this, right? So what I do ask is that if you came in late or you came in early, please turn your cell phones off, because when we're recording this for archival, this is going to be like locked into YouTube here forever. Please don't, I want to have a phone. Oh, hey, Jerry, I can't believe it. Really? Really? No. He did what? Really? No, let's not have that part of the camera. So turn your cell phones to, and me too, turn my cell phone to vibrate if you can, or even off would be great. So make sure that's all good. Okay. And we'll get started in a second as people are shuttling in. I do also ask, if you're coming in late, don't walk in front of the camera path. So there's a lot of room in the back, and there's a lot of room here. And, if you're going to, you can come and have a seat here, because they really can't see you, but don't walk across does that make sense? Like, across the camera path like this to get here. So you can kind of get there, but go like halfway, and there's a little zone of like video, no crossy kind of thing. There's a hand. Yes, a hand. Tell me your name. Ambiga. Go ahead, tell me. Yes, indeed. We're making these awesomely archivable, put online as soon as we get them mastered. Because you'll notice, by the way, there's a spot on the left. This is going to be really cool. We've done this before, and we were highlighted nationally by PBS as like a technology way to do this. I'm going to put my head in that slot on the slides. So it's kind of cool. They're going to do it for me. My team is going to do it for me. I'm going to stand here, give my job. I can't move my feet. It's going to be really weird, like not move my feet like this. But I'll do my lecture, and then they'll cut my head out, remove the green screen background, and put me right there in that corner. So I'm going to be going like, and then the slides, as you see here, and I'll be like pointing to the slides. It'd be really cool. If it works out, it'd be really cool. It's like totally rock star. And people across the country who are making recordings for their classes, look to this class. Because we did this back in 2012, and they said, like, you should see what Dan Garcia and CS10 has done in terms of a way to do this stuff. So it's really great. And it captures the energy. Like, nobody wants to hear a stand-up comedian sit in a room and record his jokes, right? It's more fun to have the live presence and the energy of the people. So that's why we do this. We actually recording this live and spending a lot of work getting this done so that we capture the live energy of the performance rather than like me quiet at a table teaching you programming. Come on. Much more fun to be up and animated and fun. I'm also from New York. I use my hands. Come on, crazy stuff. All right. So I think we're ready to go on my side. I got 11:10 over here, 11:11. Let me make sure all my mics are recording. It's got like 9 things I got to record here. That's good. Put that there. Almost here. I'm going to look to my lead people. I have to stand in my spot. Okay, so what's going to happen is I'm going to start by saying welcome to BJC. I'm going to try to use the word BJC, Beauty and Joy Computing, instead of CS10, because BJC is how we're using. Nobody, taking this course on edX knows it's called CS10 at Berkeley. CS10 is just the Berkeley name. So in Universe, I'm going to try to use BJC. So I'm going to say welcome to BJC, and then you're just like a woo. Okay, so it's to kind of like the light with like audience applause, just so that there's a little, like energy and love. Is that okay? So we'll try to do the thing. So those who came late, the idea is we're going to do a little bit of snippet of video, kind of summarize the class, then we'll talk, and I'll walk around. I don't have to keep my feet there. I can walk around, give the love, and then go back to my mark, and then we go back and get another 5 minutes and then answer any questions. So you're actually going to have more interaction than ever, because normally a class goes and some people just drone on for the whole time. Right on the board, you're just copying. First of all, you're going to note that in your hand, if you don't have this already, you have a handout, which means every single lecture, this is awesome, you don't have to take any notes. Huh? How about that for that? How about that? How about some love in the room for no notes? So if you didn't get them, you may not get notes. I'm looking around, you may not get notes here. Uh-oh, a lot of people. They're always on the chair as you walk by. If it was a snake, it would have bit you. So, while we're still here, we got my superstar veteran TA Max is going to help out. Let's give a hand for Max over here. All right. So raise your hand and yeah. So please do note, always have handouts. They're always in the chair, okay? Unless the copier messes up or something like that. But we should have it good. I'm waiting for my video people to give me a plus. They're still saying no, so they're still waiting to adjust. Got some stuff. It's not like we had an hour to set up before. It's not like we had a lot of time. I mess with it. I love it. I mess with it. It's great. So, right here we go. Let's do some questions. While we're here, we can do some questions. What do you want to know about CS10? Enrollment. Oh my God, enrollment. Right? You're probably like, I'm not in the class. Blah, blah, blah. So here's the rule on enrollment. I'll say it once and it's done. Everybody gets in. Hey! We've never said no to anybody else. We've taught this class since 2009, and I have never, ever turned away a student. And I'm not going to start this semester. We're going to make it work. So you're all in. How about that for some pro-student-centric policies? Okay? You're going to find this class in every single aspect. We're going to work you hard. I'm not going to say we're not going to work you hard, but every single aspect is going to have a policy that leans toward the student rather than toward the instructor. If it's harder for us but easier for you, we're going to go with the easier for you, harder for us model. Okay? It's always in the tune of the instructor, in the student. The students are always the central key of this. All right. Max is handing us stuff out. We can have that keep going. I'm looking for Michael and a thumb for my people. Okay? Are we ready? All right. We're going to try this. I'm very excited. I'm going to start my timer. 6 minutes. I'm going. Nonstop, and then we talk. Okay? 6 minutes video, nonstop. Here we go. This is our first thing. All right. Shoo! So here we go. Dan, I'm so funny. He gave me the thing. I said, right? You'll get used to it, but it's my first time. Okay? This is BJC Lecture 1, 2015-01, 21. Okay. And action. Okay. Here we go. So get ready for the thing. Okay. Don't yet. All right. Okay. I'm looking at my camera. And that was just for this. This was just to get to synchronize the sound. Now is going to the actual moments. Okay, so ready? Camera here. Okay. So excited. This is great. Okay. All right. 3, 2, and they never say 1, by the way. They always go 3, 2, and then they point. So, okay. 3, 2. All right, folks. Welcome to the Beauty and Joy of Computing Lecture 1. Woo! All right. This is so awesome. I'm so glad. So my name is, let's see if my animation works. My name is Dan Garcia, and I'm really delighted. I'm a senior lecturer here at UC Berkeley, and I'm really delighted to bring this class to you. This is coming to you via edX, and it's the live experience we're capturing for you, and all the students in the room are going to give you that energy and make this a really exciting process. So the slides are here. It's kind of cool. One of the things you're going to learn about BJC is it's a lot of fun. Very rarely do you see the goal in classes to be fun, to learn a lot, but to have fun. But it's going to be a lot of work. So I want to make sure you buckle up your bootstraps. Is that a phrase? I'm making this up. Buckle up your bootstraps and tighten your belt and let's go, and we're going to have a great time. If you're interested, go to the BJC homepage, whose URL is down here, and you're going to see tutorial videos and folks who are testimonial videos who are saying, this course really has changed my life, and it's just really inspiring to listen to all the folks for whom this course is affected. It's just awesome. So we always do a computing in the news, and the computing in the news today is that BJC, here's my little logo, I should give some little love here. BJC has gotten a $7.5 million grant to take this course to the New York City School District, which is the biggest school district in the country, and to work with 100 teachers to train them to teach this course, to bring computer science to the masses. The goal of this is a local Berkeley course. When we teach it here at Berkeley, it's a non-majors course. And the goal here is to bring this to the world, to bring computing to the world. We are so passionate about computer science and so passionate about computing and what it can do for people that we feel that not enough folks in the country are getting it, in the world are getting this. We need to bring this to broaden participation to everybody, so that's the goal. AP Computer Science Principles is a new course for the whole country. It's for the world, actually. The College Board has these AP courses, which are high school courses you take, that are college-level courses you take in high school. There's a new course coming around the bend called AP Computer Science. The first exam, like the first school year, is fall 16, spring 17. So that right now, AP is in parentheses because the course isn't live yet. When it goes live, we can take the parentheses off. We are a 2-time national pilot, and BJC is one of the national leaders in sharing the vision of CS principles. It comes with a curriculum framework. The picture you see there is a picture of the beautiful new curriculum framework document, which talks about all the ways that you can teach the course, the framework for it. So there are 7 big ideas that are listed here. And they're amazing. They're so empowering. Abstraction, we're going to see, is the biggest idea in computer science. And big data, and programming, and algorithms that underline the programming, and how the internet works, and the global impact of computing. Really, really powerful big ideas. Data is just so important as well. So these 7 big ideas underlie the entire curriculum framework, and they also support the 6 computational thinking practices. So these CT practices are amazing, and they are the things that you're going to do. Like, what do you do in the class? Here's what you do. You connect computing to other disciplines. How would computing relate to law? And you make that connection. You're going to create computing artifacts. An artifact is something you could drop on your foot. So it's something you would make. You're going to create a program, or you could use a computing tool to create art, or to create something for your own interest, or to solve a problem. So create an artifact is use computers in some way. You're going to abstract, so not just learn about what abstraction is, but you're going to abstract yourself. You're going to design abstraction. That's really important, and understand what that is. That's part of what this lecture is about. You're going to analyze problems and artifacts. You're going to communicate your ideas and your results, and you're going to collaborate. And very rarely do you even see collaboration on the list of things people ask you to do, and that's part of this class, and that's really important. So beauty and joy computing in one slide is a lot of ideas, but we have a big ideas of programming, lots of things there. There's the beauty. Why do you call this beauty and joy? Well, the beauty and joy because, A, we have kind of, if you have a face-to-face experience for learning this course versus only purely online, you might have some CS Unplugged activities where you use your body in different ways and think about how the computer works, not with a computer in front of you, but actually by making like a linked list with your hand or some kind of a game where you're learning this. We have some of our TAs in the room who have done that. If you're doing a face-to-face, all of our lab work is going to be paired, which means you're never going to be alone doing this. Now, if you're online, maybe you can pair up and work together to do that. You're going to have 2 performance tasks. One's called the Create, one's called the Explore performance task. Those are times in the AP, when the AP goes live, for you to actually have an authentic experience building a program and researching a computing innovation where you're thinking about what that is, you're writing it up, you're coding, you're working together sometimes, and you're producing something that gets submitted to the College Board at the end. That's for their exam when that goes live. We also have the big ideas of computing, and the big ideas of computing have many, many pieces. There's going to be a daily computing in the news, how the internet works, and lots of other interesting, wonderful lectures, including, if you have access to this, Finch robots. It's going to be really fun with that. We're also going to have incredible, easy-to-learn coding. We code in our language called Snap, which is based on Scratch. It's amazing. We stand on the shoulders of giants. Scratch is a language that has now millions of people around the world programming it, and we took that and made a version of it that is, I think, even more usable and powerful. We're going to talk about what powerful means later in the course in terms of all languages being equally powerful, but we're going to see that later. It's really exciting, and that is a torus knot that I made 2 days ago in the variant of this language, which is called BeetleBlocks, but we can show you that at the end. So anyway, I want to really say welcome to BJC. It's an exciting course. You're going to have either a semester if you're doing a college version or a whole year if you're taking this in high school, and welcome to the family, folks. BJC, woo! All right. And cut. Now, I'm off camera, and now we can just talk, and now let's do some stuff. So, the format of this course, I'll go back to here if you want, so I can record this for the other folks. I'm going to record here, but I can also talk and we can relax. So this is the point where we can, if we have some questions here, we can do this one. Right, ready? So let's go to pause it or do the thing, tell me what to do, give me a thumb, and back here. All right, welcome back. Now we're talking about how this course works at Berkeley. And so the slide right here, the slide has the word CAL here. And CAL means that these are local things, not for the edX version, the archival version, but for you guys at CS10 here at Berkeley. So the format you're going to see is a lot of work. This has the most number of hours per week of any course on campus. I'll pause and let you reflect. This is a lot of work, folks. I really want to make sure expectations are clear going into this. This is going to be a lot of work, but it's going to be good, fun work where you're learning a lot. And the other difference is, many courses, this course has no more than 12 hours a week of work. Most courses have fewer contact hours than we do. We have 7 contact hours. We're talking to you face-to-face 7 hours a week. Most courses have a couple hours, like 3 hours, 4 hours, and then you go home and then you bang your head against the wall. I can't solve the programming problem. I can't solve the problem set. I can't do the homework. Here, you're working in lab, so when you're getting confused, your TA, your lab assistant, your reader is right helping you right there. So it's awesome. So we kind of spin it. So you still do the same 12 hours a week in terms of a class. It's just that we'll be with her to help you. Okay? You're going to have readings that will be available on the website. Very easy. All the resources are free. We're going to have clickers you're going to use. I'll talk about that in a second. Clickers, free. No other class on campus gives their clickers away. We give them to you. We bought them, give them to you. You have to pay nothing. 0 for this class. How about that for giving it out? Okay, yeah, right? Remember, I said every single policy is student-centric. So rather than make you buy the clickers, we'll buy them for you. Okay, that's an example of that kind of thing. We're also going to do pair programming where you're going to work together in partnerships. And my TA is going to make sure that every lab, for at least the first couple, and we're going to hope most of them, but at least we're going to guarantee the first one, you're always working with a pair, with a partner. One computer on, and then one keyboard, one mouse, and one person driving it. The other person sitting next to them as a pair programmer. So they're the navigator. So they're the one telling you, no, don't do this. Click that way. No, maybe it's 14, and tell me what to do. And then you switch, driver and navigator. Then you move the keyboard over. Then they drive and navigate. But the navigator, by the way, can never grab the keyboard and never grab the mouse. That's a rule of pair programming, okay? And you switch every 10, 20 minutes, 15 minutes, like that, okay? And so here's a picture of some of the readings you'll do over the course of the semester. In particular, Blown to Bits is an amazing book, and you're going to have some select readings from that. It's an incredibly easy read, and it's really, like, you almost don't want to put it down. It's so good. To get questions answered, you're going to go to Piazza. Piazza is a Q&A site. It's really remarkable in terms of being able to have a wiki-style response for things. So when you want to go to get online to get help, go to Piazza, and they can show you how to do that in lab. Very easy. As I said, all the policies are student-centric. We have a set of sprinkle points at the end of the semester called APA, EPA. And APA stands for Effort, Participation, and Altruism. And the idea of APA is to allow you to get bonus points at the end for being a good citizen. Huh? How about that, okay? Here's what a bad citizen is. You just come to class, and you don't say anything, and you even skip class, and you leave, you show up for the exams. That's a bad citizen. What does a good citizen do? Good citizen goes to every class, goes to as many office hours as you can, goes to all the labs and discussions. The TA knows your name, so you're really active. You raise your hand in lecture and discussion. I'm going to have a chance, like right now we could have chance. Now we're kind of half on camera and not the archival one, so you can raise your hand and ask questions. I'll have a second for that. We want you to also be talking on Piazza and answering questions and asking questions. If you're using that actively, we can actually track that. And at the end, we actually use that as part of the APA points. We also want you to help each other. This class is not a curve. This class is an absolute graded standard. That we've done this enough years, we know what the standard is. And all of you, how many classes say, all of you can get A's? And in fact, I want all of you to get A's. How many classes say that? Almost none. So most classes are curve. Big classes are curve. We have 300 students here, yet you could all get A's, and I'd be the happiest camper ever. So the goal is, how do you get there? You all help each other. You form dynamic learning communities, and you help each other on Piazza and in lab. If you go in lab and you finish lab early, why leave? You go to your TA, do you mind if I get up and help my other students? They say, sure, and they'll bless you to get up and help other people in the lab. It's about helping each other and getting you all over the mountain. You're going to have 3 slip days. These slip days allow you to be late on things. My dog ate my homework. Excuses are gone because you have these 3 tokens, each a day apiece, where if you pay the token and you're a day late, you're not counted as late. Basically, it's a free 3 days late that you can distribute across the semester. I would reserve them and wait till you have big ticket items like projects. Don't use it on a small homework, which is worth this much. Use it on a project, which is worth this much, to give you more time. So most students save them till the end, to the last project, which is worth a lot. So think about that in terms of how you use your slip days, okay? I'm done with my Cal questions. Now, 3, 2, 1, and action. Actually, I'll stay on camera, But you guys can ask questions. What else do you want to know about? I told you enrollment, you're all in, okay? How many of you have programmed before? Raise your hand. Okay? If you've programmed before, you can't really be in the class. So there's a bit of it, which is, this class is for people who have never seen programming. There's a class 61A. We're not calling you out. I'm not giving your names or anything. But I'm going to ask you to move on to a class called 61A, or the Self-Paced Center has a lot of cool courses to learn a language. If you want to learn Python, or Java, or C, or Unix, there are other courses you can learn if you've programmed before. This course should be all non-programmers. How many of you have not programmed before? Look around. Now look around. Okay? People often get scared, like, oh my God, I've never programmed before. The whole class essentially raised their hand. So you're all safe. It's going to be a safe, wonderful place. You can partner up with people in your lab who are just like you, who have probably not programmed before. And if anybody has a little bit of programming, we'll try to get those guys programmed together, those ladies or guys to program together, okay? So I want you guys to feel like you are totally safe here. It's going to be awesome. It's going to be a really hard experience because learning programming is hard. Getting your brain to work the way computer scientists work is really hard, but it's going to be really good work. I keep saying hard, but it's going to be good, hard work. I want to make sure that I emphasize that, okay? And we're going to start you off like go. Like the moment lab hits, bam, you're in to the way this is going to work. I thought, give me a second, I thought I had a slide on the semester and how the semester ran. Let me see if I had that here. Weekly schedule. I hid this. I have 3 hidden slides. Look at that. So here is the weekly schedule, not on your thing because it's on the website. So how it looks like, just real quick, is there's lecture Monday, then lab between, see the red thing, lecture, right? So then you have labs, which are the blue guys, then lecture again, then lab again. So you have 2 2-hour labs, okay? And then discussion on Fridays. That's how it works, right? So basically it's kind of like Monday lecture, Tuesday lab, but you could have lab on Mondays or Wednesdays too. Wednesday lecture, Thursday lab, and then Friday discussion. That's the idea there, okay? And cs10.org is the website, okay? Part 2 of hidden slide is this. As I said, we never drop anybody. As of yesterday, there were 8 waitlisted, but we're going to open that up and allow everybody in. So that's a good thing. And also people eventually say, this is not for me, it's too much work, and they'll make more space for people who come in late also. So don't worry. Everybody get in. We're going to have this thing called clickers, called peer instruction in class, just to set you up what we're going to do. We're going to hand you the clickers in lab starting this week. So that way, next Monday, you all have them, we can start them. Okay, I'm going to record this. I'll click go on the clicker, and I'll ask a question. And that's the part that's not on video, right? So it's like, I give you 5 minutes of lecture, and then, bam, here's a question. Here's a clicker question, a multiple choice question. You'll all answer the question to your best of your knowledge, and then you'll pair up. And I'll have everybody pair up, and you'll talk to your neighbor about what you said. I said A, you said B. Why would you say A? And you talk about it, okay, for about 3 minutes. And then we come back and you vote again. Your goal is to convince your neighbor of why your answer was right. And what's funny is sometimes you say A and they say B, and after you talk, the answer ends up being C for both of you. It's kind of fun, where you kind of combine the best of all worlds. You vote again. And then if all the votes converge to the right answer, we move on. If all the votes are still scattered, we stop and we do a directed learning right there. So it's a great way to make class active learning and stop. If anybody's confused, it's a way to stop and get those questions answered. And that's a Q&A. So don't feel bad that you can't ask a question during my video time. We have a lot of clicker questions. More clicker questions than ever in CS10, because I'm going to insert them basically every 5 minutes. So it'll be really cool. Okay? So now I have time for any other questions that I wanted to. I see a hand there. Yes, go. And tell me your name first so I can learn some names. I'm Maddie. Go. Yes, it's a deposit. You get it back at the end of the semester, but that's right. There's a check that you get. I'm writing this, so you get a check. We collect a big bag of checks. We lock it away, and then we give it back to you at the end. Yep, you can tear it up. Yes, in the back. Name. You did not. What was your name? Evan. We did not have section. I sent a Piazza mail to everybody I thought was on the list to say don't go to section. We didn't have. You didn't miss anything. We always start with lecture. More questions? Yes. Tell me your name. Hike. Go. Yes. If you have your own clicker, please save us the trouble of doing the transfer. Yes. Yeah. Use your own clicker if you have it. Yes. Click. Name and question. Rachel, go. I'm so glad you asked that question. That needs to be part of the fact that we have. You can attend any discussion you want. You can even attend all the discussions. Discussion's a room like this, where we can just add more chairs or get a bigger room. So discussion is always open to everybody. Sample around, find the one that's convenient to you. We don't care what you tell Sproul and what you actually do. They can be different, okay? You Sproul, you sign up for Monday, Friday at 10 to 11, but you go to the 4 to 5, who cares? Nobody cares, okay? It's all fine. We're just going to work out. And if one TA gets overwhelmed because it's a popular time or they're a popular TA, we'll get a bigger room for them. So it's very easy to expand the space. We do have, though, multiple times, section TAs at the same time. So actually, we even have multiple TAs covering the same time. So you could even go every other week to see which one you like better for that same time, whatever. All casual, very easy. Lab is different. We have 30 lab computers. So we really can't have all the students decide that, 12 to 2 is convenient. They all go to that section. That wouldn't work, obviously. So long story short is you have to start with your lab that you're signed up for, but you can switch on Piazza. Hey, does anybody want to switch to add to this one? I need to move to that. And you can try to do some switching and maybe some casual time where you can talk to your TA. Hey, is there any space in this lab? I want to move to them. And if they say yes, you can just grab it. Okay, so, but it also doesn't hurt if you bring your own laptop into lab because there's only 30 computers, but there's more space on free tables for you to be sitting on the floor and doing this. So we're very flexible about having larger lab sections, people on their own computers. Totally cool. Great question. I saw another question back there with a hand. Yes, right there. What's your name? Diane, go ahead. Correct. There's a lab discussion I think there's one right after this, actually. I think there's one right. I had it on the calendar a second ago. But yes, there's a lab and discussion right after this. Weekly schedule. Bink. Yep, right after this. Lab 1 is right after this. Jacqueline. Jacqueline's in the house. I think Jacqueline's in the house. Jacqueline was here. Anyway. Was it Jacqueline? Wasn't she here? She was. She left. Okay. Question. Go. Yeah. Name. Terrence. Go. No. Lab was canceled before class. Now that lecture happens, lab is good. We're going live. We're live in lab, live in discussion, live in lecture. Yes. More questions. Name. Riccio. Go. Yes, we prefer people work inside because there's going to be times where we actually dedicate a whole lab section for you to work together. And so if you're not making use of that, they're not in the same lab. But yes, technically you can work outside a lab. It's better to be in the same lab section if you can't do it, though. More questions. I love this. This is great. I saw there was a question. I saw my visual field. Yeah, over there. Name. Marissa, go. Yes, you have to go to lab because there are reading quizzes in lab, but there's also checkoffs in lab. So this requires you go to lab, you put all your books down, you take a reading quiz to prove that you did the reading from the weekend. So reading's on the weekend, basically, in general. Then you do the reading quiz, the first lab of the week, usually. You answer some questions, and that gets graded. That's part of your grade. It requires your lab. And then when you're done with lab, there's going to be some checkoffs where you get done, you raise your hand or put your name on the board or however the TAs work it. Then they'll come around and talk to a TA or a lab assistant. As I said, we have more lab assistants than any other class, period, per person, per section. It's ridiculous how many people give back to this class. And we encourage all of you, if you like this, to give back next semester and past that. By the way, all the TAs, every one of them to a person is a former CS10 student. It's not like I got a grad student from this and they came in, they don't know the class. Everybody is part of the family. They've all been in my class learning from me, and they've all gone on to work their way up the chain to be TAs. It's awesome. They really love this class and they're really passionate about it. You're going to find, rarely will you find a more dedicated group of TAs than in this class. It's really amazing. It's so wonderful. Other questions? We're doing great. Yeah, more. Your name? Hi, go. That's right, you said. No reading quizzes in lecture. Oh, by the way, no reading quizzes in lecture. The clicker questions that you answer are not graded. This is very important. I will give you credit for taking the clickers and coming to class and clicking. I will give you kind of attendance credit. I don't care whether you get it right or wrong. So it's like, I could ask a confusing question. If you get it wrong, it's not like, I lost some points. You didn't lose any points. You got credit by voting. So it's very cool, right? It's more student-centric. Learning is a squishy, soft process where your brain is still forming it, and we only really care at the big, hard deadlines. Even, by the way, even a checkoff in lab, if you're kind of fuzzy with your answer, your TA won't go, wrong, and you get no points back. They'll say maybe think about it here or go back to this exercise, and they'll come back to you and give you full credit. The point is, if you get it, if you know it by the end of the lab, you'll get full credit. It's not about getting you wrong. It's not about assessing you. It's about getting you all over the hill. We want you all to get full credit in the clickers, because you just come to class and vote. We want you all to get full credit in the lab work. Okay? Reading quizzes are different. We want to make sure you do the reading. If you don't know, we can't give you a second try. Right? You have to really do the reading to do that one. That's a little different. It's like kind of an exam. Yeah. Cameron. Check whenever you have it. Check whenever you have it. You can also have your buddy write a check. I mean, if you have a friend who has a checkbook, have your buddy write a check and then give them money. Then it's done. So it's easy. It's very easy to do that. Okay? I see a hand. This is great, folks. Anything you want. Remember, this is like really, really very dynamic class. We'll be able to talk and do this, but I'll have these moments of video and then time to talk. Yes, in the back, go. It's a great precursor for 61A because 61A is in Python, and as I said, doesn't require you know programming, but they start pretty fast, right? So this is a great semester to learn some really powerful ideas, and my TAs are going, yes, yes, and then we even teach you Python, which helps you explicitly with the language issue. So if it's about the language, at the end, we're going to teach you Python, and then have about 3 or 4 more labs, right, and give you a programming project at the end. You could choose to do the labs in Python. Once they teach you Python, you can do Python from that way out. If you choose that, then you're locked in and you'll like get a lot more experience. But if you don't want a Python, just like, I know what Python is, but I'm not going to use it again, you can go back to Snap and use Snap. So you can just have a 1 week of Python and go back to Snap. Like, what was that crazy text typing thing? I don't like this. It's like a piece of stale broccoli. Then you don't have to have it. And you go back to Snap. But you could also choose to lock it on Python and be really prep yourself for next semester. So we really want to help you guys who want to go on to 61A to do that if you can. Yes, question in the middle. What's your name? Ishan, go. Snap Decal is connected in the sense that people who are former students are passionate about software development and language development are working on adding features to the language itself. So the answer is yes in that sense. And we're really pleased that people really care about Snap in that dimension. Remember, I said people give back as lab assistants, readers, and TAs, and additionally as Snap developers, additionally as edX developers, as video people. I got a ton of people helping make this class rock. It's amazing. 4 things. Yes, name. Claire. If you learn some programming in Java, you're probably more too advanced. Like, I don't know how much you learned, like a week or a semester, but if you learned that, you probably should go on to 61A or another class. As I said, the Self-Paced Center, for programmers, your requirement is to be a programmer. After graduating from this class, you're a programmer, okay? So you can take and learn any other language from this. And the Self-Paced Center is a self-paced way, which I used to run, to learn other languages like Python, like Java, like C++, C, Unix, other things, okay? And MATLAB, it's great. Last one? Yeah, go ahead. Name? May, go ahead. You can go to any discussion. As long as you're in the class and registered, like if it's letting you register for the class with the conflict, then who cares? Sproul is happy, I'm happy, go to any discussion you want to. Is that okay? All right, are we good? Awesome, I hope I answered everybody's question. Oh, one last one, yeah, go ahead. Yeah, sure. Oh, 2 1. I saw there was 2 in there, yeah. It's blocks-based. The question was, is Snap like App Inventor? It's blocks-based like App Inventor is, but it's different. App Inventor is geared on making an app, and I think the semantics are a little bit, semantics like how the programming language works are a little bit confusing. So I prefer our language a lot over App Inventor. I've seen App Inventor, and I think it's a little clumsy at times. So I actually think people are like this more. People who've done both actually find that just a soft sample I've done of people find that I like Snap better. Is there a question right in front of you? Yeah, what's your name? Emily, go ahead. If you can't make a discussion, then ask your friends to get notes or go to other ones, and we'll also try to have all the notes that happen in discussion on the website. So we'll try to help you as much as we can. Okay? Yes, go, name. Danielle, go. Great name. The midterm and final both have a lab component. That's a good question. If you look on the website, there's a question, there's a really hard question that we would have given you on the exam that we pull out of the exam and we give it to you in lab. And we actually randomize it. We actually kind of change the variants so like all the labs have different questions, but they're all the same difficulty, all the same flavor. And so you're going to actually have to go to lab right before midterm and right before, I mean, you're supposed to go to lab all the time anyway, but you're going to have one lab that's like, oh my God, I'm having an exam question. It's only worth 10 points out of the 100 points of the exam or something, but there'll be a question in lab right before the midterm and final. Good question, yes. Okay, yeah, and the after, there's an evening midterm. Is that what you mean, Michael? The midterm? Yeah, so there's going to be an evening midterm. There's going to be, okay, so exam-wise, there's going to be one quest. It's like halfway between a quiz and a test. We call it a quest. A quest, the glorious. Okay, Mantle La Mancha, anybody? Okay, so we're going to have a quest in class, like about the 4th or 5th week, just to kind of make sure you're all here. And you all should ace that. It's going to be like probably just very questions you've seen from lab. Nothing's crazy or hard, just a very reasonable quest. People get their confidence up. Oh, I love this class. I can do this. And by the way, it's going to be before the drop deadline. So if you don't do so well, like, yeah, it's not working for me. I'm going to convince you all to stay with it anyway, because we had this awesome policy that you take a midterm also. And if you do better in your midterm than your quest, we replace your quest score. We have a final exam. If you do better on your final than your midterm or quest, we replace both of those scores. So you can always, like, show us you know the material and then, like, totally get full credit. Huh? With the student-centric policy, we're telling you? There we go. Snaps, right? Very good. Okay. All right. Anything else before we rock on? I got a little bit more material to go with. All right. Boy, so glad to have you. By the way, there are seats. I see about 10-ish in the hallway, and there's way more than 10 down here. So in general, we can fit in this room, which is nice to know. But feel free to sit in the hall. Sit in the aisles for now. But please do try to get a seat in the future. Okay. So I'm going to set my timer. I have to put my thumb here because this thing goes to sleep and wakes up. All right. Timer. Here we go. Okay. Get my slides ready. Take a little drinky drink. Okay. Here we go. Starting now, you can be tested on this. Before it was just like, welcome, blah, blah, blah. Now you're being tested on this, okay? Here we go. Okay. Set timer. Here. Thumbs up over there. And 3, 2. All right, welcome, folks. Now we're going to learn about a really powerful idea called abstraction. Abstraction is often thought of as two main ideas. The two ideas are detail removal and generalization. And detail removal is the idea that there's just too much complexity. I need to be able to just focus on the important things of the model, of the system, and I just reduce the detail. Generalization says, I've seen multiple examples of something, but that's really one example with just different variants. Okay? So we'll see that in example. Right now I'll go into the detail removal part of it. So detail removal, here's a beautiful example of that. You know, you're going from A to B. By the way, this slide is courtesy of my colleague Manish Agarwala, who does visualization here at Berkeley. So he had the problem that Google Maps and Bing Maps and other map systems are great. We love them. They show all the detail, all the roads you'd go to, all the little coffee shops, but sometimes it's just too much visual noise. Sometimes it actually helps to erase some of those. And so if you've ever seen wedding invitations, Google online, I encourage you all to say wedding invitation maps. And you'll see these really cool maps that are usually hand-drawn by artists. And they show just the important lines that you need to go. Okay? Not all the lines, just a couple of the key lines. This is where you turn left at the Shell station. This is where you pass the airport, etc., right? So the goal of this work is to really capture the idea of detail removal. If you just need to go to A to B, doesn't it help to be able to erase some of those lines automatically? Wouldn't that be cool? So his software, his team's software, did that. And they took original Google Maps, I think it was called Line Drive, and they only showed, and they even drew them as if they were hand sketched. So the result on the right looks like a hand sketch, but it's done by a computer. So you say, I need to go from here to Whole Foods, and it basically shows the key points that you'd go, maybe 2 options if you have 2 options to get there, and erases all the middle ones. Isn't that neat? So that's a great example of detail removal. Here's another great example in BJC. So here's how you see detail removal in BJC. So you want to simulate a game, or write a game, or do a simulation, or write a program. And the amount of complexity is just too much. Let's say you wanted to do a traffic simulation. Well, do you start by modeling cars and the steering wheel type they have and what kind of digital radio they have? No, if you're just doing traffic, you don't care about all those details, right? Nobody cares about it. Do you care about what belt the person wore that day? No, that's a detail that might be part of some simulation, but not your simulation. You care about X, Y, and where the traffic might be. So what's one way to think about how you might abstract away the detail of a whole car and a person and their thoughts and desires into the simplest possible thing? Maybe from top down, an XY coordinate on a plane, right? And a dot represents the whole car. And now you're just showing a visualization of the dots and how the dots are flowing. And when the dots are really high, maybe it gets red or something, you're showing some visualization. So that's an example of throwing away the detail of the car and the person and the fears and desires and just focusing on the smallest bit that's important for that simulation. Okay, that's a great example of detail removal, in addition to the map example. So abstraction in general is the idea that you focus only on the essence. What is important for what you're trying to do? Another example we've always given is if you ever are in an elevator with Steven Spielberg. This is called the elevator pitch. You better have your movie pitched in 10 seconds. So what you do is you boil the whole movie down. Okay, guy and a girl fall in love on a boat that was big and expensive, but faded because it hits the iceberg, and they all die except some survive, but the guy and the girl, one survives, one doesn't. I'm sorry for giving this away. But the point is, I summarized Titanic in 10, the guy's like, I got it. What do I write the check to? Green light, right? He would love that. So you got to summarize your pitch. What's a good joke? A good joke is all the details of the world. You don't start a joke by saying, okay, there's two guys go to a bar. One guy's named Bob. Bob was kind of a middle-aged, he had kind of a little freckle on this side, and he had a shoe that kind of, no, you don't say that, right? You get into two guys walking in the bar, and an alligator says this, and a hat, right? You get into the detail. You cut the detail out to get to the essence of it, right? A good joke teller goes right to the punchline, right to the key thing that's needed for the joke. It's exactly what abstraction is about. So the pitch you might give to a movie guy, a good joke, a map, a simulation, all those are examples of trying to remove the detail for what you don't need to focus on what you do need. Complexity is going to get overwhelm you anyway. You've got to focus on that what you need to work on. Okay? So, in summary, that's detail removal and the basics of abstraction. Next, we're going to talk about generalization. Cut. All right, now we can talk. Are there any questions about abstraction and detail removal for now? You guys get that idea for the most part? Okay? All right? All right, so let's go to the next part. Great. Okay, 3, 2. All right, welcome back. Now we're going to talk about generalization. So in generalization, it's the idea that you see multiple copies of things. You're like, wait, that's the same thing. Why do I have to do this multiple times? For example, I love this example. It's not on the slide, but it's an example. And then I'll do the slide example first. So in the joy of cooking, this isn't on the slide. This is on the slide. In the joy of cooking, there is not a recipe for a cherry. How do you make a vanilla milkshake? How do you make a vanilla milkshake? It's like a little bit of ice cream, a little bit of milk, a little bit of sugar, maybe some vanilla extract. Okay? And then some cherries to make a cherry milkshake. What's a strawberry milkshake? Little ice cream, little milk, little sugar, a little bit of extract, strawberries. How do you make a raspberry milkshake? Little milk, little ice cream, a little vanilla extract, a little sugar, raspberries. Okay? Now you ask yourself, why does Joy of Cooking not have 3 different pages for one of these milkshakes each kind? What do they actually have? If you look it up, what do they say? They say little milk, little sugar, little ice cream, vanilla extract, add fruit. You see, the fruit was a general placeholder for any fruit you'd add there. Now, not all fruits work. There are some bitter jackfruit or weird things. But the point is, 99% of the fruits are going to be really good. Okay? That's a way that they generalized all those 3 milkshakes into one recipe. That makes sense? And the input, if you will, was the fruit you put in. Is that going to make sense? So, here's another example. You're on a farm, and you see all these signs. One sign says, to feed the chicken, you put the chicken food in the chicken dish. To feed the dog, put the dog in the dog dish. To feed the cat, put the cat in the cat dish. You're like, bah! It's the same rule. You should say what? What should you say? Class? To feed the animal, put the animal food in the animal dish. Bam. Okay? So animal is your input. And now that animal gets passed around to different kind. Okay, the particular animal today is a cat, so go to the cat thing. Now the animal is still a cat, put it in the cat dish. And it's still a cat, put it in the cat food in the cat dish for the cat. Okay? Great idea. So that's generalization in that sense. Now, here's some foreshadowing. Here's how we do this in BJC. We're going to have a connection to the mathematical idea of functions. This is a function machine. You put something in, you turn a crank, something comes out, like a sausage maker. Okay? That's a function of one input and one output. We're going to learn the next lecture, and the next kind of big set of lectures, about functions. And these functions have inputs. And these inputs are the way that you're generalizing it. I'm generalizing this guy by having a fruit as my input. You might also have fruit and a spice. You know, some people add in their smoothies, they might add, or in their smoothies, they might add like, bee pollen or some vitamins or something like this, right? So you could have other inputs rather than just the traditional one that you want to have. So you might want to have, here's this, and here is a general placeholder for a general set of other things you might add to your smoothie. So you often think about, as I'm generalizing this, rather than having 3 different pieces of code that do the same thing, let me pull that back. It's really, if I look at the 3 copies, there are 3 copies of the exact same code. This is draw a triangle. This is draw a square. This is draw a pentagon. This is draw a hexagon. What's the idea? Draw a regular polygon, right? So what might the input be in that case? Number of sides, right? You put in 3, triangle. 4, square. See, rather than having 4 copies, you have 1 copy with an input. That's abstraction and that's generalization. That's the big idea. And you're going to see this a lot when we talk about writing functions. In this class, one of the key and big ideas you're going to do is how to build the function, how to define those abstractions. How do you decide what is a function, what's not? What should be the inputs, what shouldn't be? What should be a constant, what should be separate things? All those will teach you and you'll get experience with doing. Is that awesome? All right, so you've just seen the example of generalization, and we're foreshadowing a little bit what you'll see in this course. Awesome. Bink. All right, questions about generalization. Now, see how this works dynamically? Slides, and now time to talk, and this would be a clicker question in general. You guys get it, generalization? Okay? All right. All right, how am I doing for time? Just do a quickie check of my time. Doing great, okay? So now let's start. 3, 2. All right, welcome back. We're now going to talk about the power of abstraction. We saw that generalization and detail removal were two key elements to abstraction, but now we're going to see how there are other pieces to it. As you're defining those functions, as we saw in the last clip, as you're defining those functions, those kind of things, what you'll learn is this really powerful idea, is that abstraction, those functions are really an abstraction. As you're defining those abstractions yourself, you kind of get this soft, as I draw here, an abstraction barrier. It's a little weird. Like, what do you mean by that? Okay, what it means is, I'm going to have this layer that defines what those inputs are. That's the definition. That's what's often called the spec or the contract. I think we also call it the interface. Okay? Spec, contract, interface, all for the same idea. Those are kind of like, okay, here's a function. Inside, it does something. It makes a smoothie. It feeds a person. It computes sign or something like that. Okay? And there's some inputs to that. And here's the really powerful idea. Okay? Below the line is how it does it. Okay? And how it does it is different than the person using it. How it does it is the person who actually implemented the smoothie. If I go to a guy, make a smoothie, I say, I'd like a raspberry smoothie, I walk away. I don't know how they're doing it. Are they going out and planting a raspberry patch and waiting, and the raspberry gets harvested, and they come out, and then they're actually milking the cow themselves? I don't actually know what they're doing. Are they actually beating it fast or putting it in a blender? I don't know how they're making it. And here's the best part. I don't care. That's the most powerful idea here is below that abstraction line, you don't care how they did it. They just did it. Hey, can you actually put in a hot tub for me? Sure. How much to put in? $10,000. Okay, here's my $10,000. I don't care how you did it. I just wanted a hot tub. What's the spec? The spec is the agreement we had. Whatever that part of the contract is, that's the agreement. Here's the cost. That's part of the spec. Where it's located is part of the spec. How long it might take is part of the spec, right? Turns out, watch this. I say, I want in a week, $10,000, I want a great hot tub. Great. I walk away. A week later, there's a hot tub. Okay, in a week, and it works at cost. Done. The spec contract is done. How did they do it? They could have built it themselves. They could have hired subcontractors. You heard that phrase? That means other people are helping to build it. They could have, watch this and check this out, gone to my neighbor, stolen my neighbor's hot tub, ripped it out, tied them up, put it here, installed it. There's your hot tub. I don't know, and I don't care. I mean, I care. I care, right? It's my neighbor. I borrow sugar and stuff. But the point is, in terms of the abstraction, I got what I wanted. I got what I paid for. So I'm not supposed to know how they did what they did. That's the other piece of it. I'm not supposed to know that. Okay? I don't know how they made my smoothie. I don't know how they got me the hot tub. It just happened. The people above the line are people like hiring the contractor, people using the abstraction, people calling the function, people requesting the smoothie, people requesting to feed the animals. How they actually get done, I don't know. It could be that the person feeding the animals scatters them to the winds, and all the birds from Mary Poppins come down, and they put all the food and the right dishes and the singing songs on the shoulders. I don't know. I don't care. It happens behind my scenes. It happens below the line. That's the idea, okay? Below the line. Above the line is what I've asked for. That's the agreement. Below the line is how it got done. And I can't know, nor can I care. That's a really powerful idea, okay? And that's how all abstraction is managed. All the complexity of how it gets done, I don't care. General says, we're going to invade Europe, okay? And at some point, how it does, that they care, but at some point the president says, we need to invade Europe this day. We get invaded. Europe gets invaded. We, the free world is saved, right? The detail, president doesn't know, okay, Bob Jameson from Wissahickon, Utah, he climbed on the beach at that. No, it's too much detail. There's no way that president can care about or know about that amount of detail. He just said, we got to invade, here it is. Then that gets passed on to people who help with that. Then it gets passed on to lower people, and lower people, lower people. That's how it works, okay? So, that's the idea. that there's this really powerful line. Above it is called above the line. You can't know what happens below the line. Below the line is the actual implementation, the actual manufacturing, the doing it, the creating it, the building it, whatever it is, that's how it gets done. But you can't know or care above that line. Powerful idea. Okay? Next one. In summary, this is a summary of the abstraction bit. Abstraction is one of the really powerful ideas of computing, folks. It's how the most incredibly complex things mankind has ever built. Let's brainstorm of those biggest things. The space shuttle, okay? The Bay Bridge, the Golden Gate Bridge, the Titanic. Think of the biggest things we've ever done. Biggest, most incredible engineering things ever, right? Satellites, a trip to the moon. Are you kidding me? Getting a human to the moon and back? Are you kidding me in terms of complexity? All that was managed by abstraction, right? The guy at Houston, he says, communications, go. Fuel, go. Oxygen, go. What other things you need to have? Internet, Wi-Fi for playing Angry Birds, go. Right? He's going around and going to check off of his top leaders, right? Each of them are like going, are we okay? Is communications okay? Each one of them is asking their leaders. And each one of them, I'm like, literally, that hierarchy is how we got to the moon and back, how we built all those big things. You have to manage complexity at the top level. The top guy cares about 10 goes, we launch. Right? That's the top level. 10 goes, we launch. Each of those guys have their rule. They're asking their people, are we good? We're good? Okay, I'm ready. Go, and he reported to the guy above him. So this kind of layering of abstraction is exactly like how big corporations work. It's how big complexity things works, right? The top architect cares that the bridge goes from A to B. Then the lower guys care about the bonds and the this and the this and the pavement and the this, okay? So top level down, it's really important you understand how you don't care about what happens below that line. That's a really powerful thing. So by the way, the most complex things humans have ever invented are not what I've listed. They are software. The complexity of the internet and internet services and all the things that we have dwarfs the complexity of building a physical device or even going to the moon. It's incredible, all the things that we have and how many layers of abstraction to go all the way down to the computer, to the layers of abstraction that how a computer works. It's unbelievable. There are way more levels of abstraction in the things that we do now with electronics and computers than physical devices are going to the moon. Trust me, it's incredible. Okay? So, 2 definitions in summary that we've seen before. Generalization, which means you take common guys and kind of bring them together, and you have inputs that make the variances. And you have detail removal, which is basically how you make those abstraction barriers. All right? Thanks so much, folks. We'll see you next time. Woo! BJC! All right. And cut. We did it. Yay! That was great, guys. That was really great. That was really, really great. Okay. How am I doing for time? Did I run over? I'm perfectly on time. Look at that. Son of a gun. All right, stop my recording.